we're going to try and justify constructions and prove that they work. And what we're going to do is we're going to start with justifying that I can copy this angle into another spot exactly as it's there. So in order to do that, I'm going to start by simply making a line. And at the end of this line, I'm going to put point B because there's a point B here. What I'd like to do is I would like to be able to transfer the length from B all the way to A. Now the way that I'm going to do this is with my compass. I'm using the radius of a circle. And since the radius of the circle from B to A is right here marked, I can transfer that onto this line with the point on B, making a mark. And so now at this point is A. So what I'm looking for, where some of my difficulty is I need to transfer C. Well, I'm going to use the radius of another circle. And it's probably somewhat close, but I measure from B to C. And now I'm going to create an arc from B around. Now I don't know where on that C might be, but I do know that it is a fixed distance from point A. So I'm again going to go ahead and move my compass to measure that angle, or that distance. Once that distance has been measured from A, I can transfer it onto A, where it will cross my first arc. Now at the intersection of those two arcs, that's point C. Now point C, when combined with point B, allows me to have recreated this angle. So I could measure this angle, and when I line it up, I see that I'm 35 degrees. So if I come over here and I measure, although measuring upside down now, what I see is that I am still, where am I at? I am still lining it up 35 degrees, having some difficulty lining it up because I'm looking at it at an odd angle. I'm still at my same angle measurement. So I'm able to transfer that in this way. But my simple justification is that C has a fixed distance from B. So these two are the same length. Now, A to B, this is a length, and it's the same as over here. Now, if I was to complete these triangles, from A to C is a third length. So from A to C, that same length, and I've used the side-side-side triangle congruency in order to be able to prove that I copy the angle just by measuring those sides. If I was to transfer this to where I can see on a coordinate plane, it would be easier to measure with the distance formula. What if I was trying to prove something like the bisector theorem? So in order to make to prove the bisector theorem, I have to first construct a line to be capable of bisecting. So here's my line that I want to bisect. And I'm going to bisect this line using my straight edge and compass. So fixing to, or putting my point on one side, my marker over halfway, I'm going to create an arc. And at the same measurement, I place my point on the other side and create another arc. So when I join these two crosses of the arcs with a line, I've created this perpendicular bisector. Now how do I know that it is in fact bisected? Well, that would mean that if this is the center of the circle, I could draw a circle from here all the way around, and I'm using the radius of the circle as my ability to measure. So I'm able to see that if I was to mark these points and give them names like A, B, and C, from A to B is the radius length, and from B to C is the radius length. Now another thing that I could then show is that my distance from this cross to A is the same distance as it is to C. So I'm able to use again the radius of that circle. to show that from A to this point up here that we'll call D is the same distance as from D to C. So we're using these same triangle congruencies as our method for proving that constructions work. Remember, math rocks with a capital M.